This is question 7 of the GCSE Edexcel 9:1 sample assessment materials higher tier physics paper 1. A student investigates how the average speed of the trolley varies with starting height. Figure 9 shows the trolley and runway. Describe how the student can determine the average speed of the trolley. So for any of these questions, always think about what you measure, what do you measure it with, what equation should you use, and how can you make it more accurate. So we're going to use the equation speed equals distance over time, or average speed equals total distance over total time. So we need to work out or measure the distance and the time. So measure the distance between 2 points on the ramp. It could be the top and the bottom. It could be maybe here and here. It's up to you. Using, so what do you measure it with? A meter ruler, not a normal ruler, it's too long for that. Then measure, you can't really read that word, sorry, the time taken for the trolley to travel between these 2 points with a stopwatch, or you could say with light gates. So what do you measure and what do you measure it with? That would be 2 marks. What equation do you use? Use the equation V equals x over t, or average speed equals total distance over time to work out the speed. And then a really good one, if you want to try and make it as accurate as possible, to always say is repeat and average. And you have to say them both to get the mark there. So nice simple question. Part B even. Figure 10 shows his results. We can see that as the height increases, that speed is increasing too, and here's the graph. It's not a linear increase, there's a curve here. So the trolley has a mass of 650 grams. Calculate the average kinetic energy of the trolley, which had a starting height of 0.075 metres. So KE is an equation you need to know, equals 1/2 mv squared. So 1/2 times 650 grams, it needs to be in kilograms. So I'm going to divide by 1,000 and it comes out as 0.65. And then the speed, I don't know the speed, but I can work it out. So when the starting height was 0.075, that's here. I'm going to draw a line on my graph, like so, and draw a line along, and I find the speed, nice and conveniently, on a bold line there, is 0.6, and do not forget to square. An awful lot of people forget to square there, and it comes out, when we round it, as 0.12 joules. It's 0.117 joules, so we round it to 0.12. And then determine the gradient of the graph when the height is 0.1 metres. So in every couple of papers you'll get a question that asks you to work out the gradient of a curve, which is finding a tangent. I'm looking at 0.1 metres, which is here. So the first thing to do is construct your tangent. Now your tangent is the line that kind of just pushes past where that point is. I'm going to construct the tangent, and I'm going to work out the gradient. So the gradient for this, I'm going to try and find some lines where it's nice and easy to find it. I haven't done this one in advance because I didn't have enough papers to try it out on. I had to just do it for the first time. So I'm going to pick that point there, and then this is quite an easy point here. It'll be different for what you draw, it depends on your line. We're not all going to get the same answer. Okay, so gradient, remember, equals change in y over change in x. It doesn't equal y over x, it's change in y. So change in y, here, the y to start with is at this point. So that's 0.94. Minus the y here is 0.4. Divided by x. Now x for this point here is 0.1. It's this point, which is 0.17. I'm going to minus the x at this point here, which is that there, so that's 0.025, 0.015. Be careful when I do that. Hopefully this is correct. So with a calculator, like I say, I haven't done this one before. 0.94 minus 0.4 divided by, in brackets, 0.17 minus 0.015. And I have an answer of lots of numbers, but I'm going to write 3.5. And I can work out a unit. The unit is meters per second divided by meters, which would actually be 3.5 per second, but they don't care about the gradient here. I'm going to write 3.5. And the mark scheme, from what I remember, allowed you between 3.4 and 3.6, so it seems that I was mostly correct. Describe how, oh it does, yeah, 3.5 to 3.6. Describe how the speed of the trolley varies with the change in height made by the student between 0.04, so here, and 0.12, so here, no, 0.12, yeah, up to here somewhere, there you go. Right, so these kind of questions are quite common. They're always 2 marks, and they're always 2 marks if it's not a straight line, because you can't just say, as you increase the height, you increase the speed. That only get you 1 mark. How does it increase? Now we can see as the height increases, the speed increases too, but at a decreasing rate. So it's still getting higher, but it's getting higher by a smaller amount because the curve is like this. So as height increases, speed increases. Would you get your 1 mark? At a decreasing rate. If it looked like this would say that as height increases, speed increases at an increasing rate. And if it was straight line, I'd say as height increases, speed increases proportionally. This is direct proportional, something like that. So there's your 2 marks. You have to say how the 2 increase and then give me an extra bit of detail. Part C, the student wants to change his experiment to investigate how different surfaces of the runway affect the speed of the trolley down the slope. Devise an experiment that would allow him to investigate the effect of different surfaces on the average speed of the trolley. This question, it seems pretty easy to get the marks here, it seems a bit obvious. So they want to vary the surface, and they want at least 3 different surfaces. Because how are you going to work out if it's a different surface that changes the speed if you don't have more than 1 surface? So vary the surface, keep the height of the ramp and the distance measuring between. Either one of those got your mark. The same, because that's going to be your control variable. You can't make the height taller and change the surface. You can only have one thing that's varying. You're varying the surface, and then calculate a speed for each surface. And if the speed is different for each surface, then you will notice that you do have different speeds for different surfaces. You might want to quantify in some way the way that you can talk about the surface. So is the surface rougher or is it smoother? But that would be all you need to do for that question.